In this example, we are going to solve a triangle problem using the double angle identities, but also using sum and difference. The main point here is that when we start looking at these things in triangles, we forget that these rules exist. So I wanted to go through this example so that you could see it in action. So as usual, the first thing I'm going to do is draw a picture. So alpha is in quadrant 2. And the sine of alpha is 3/5. Sine is the so part secotoa, so that would be 3 and 5. This is a 3, 4, 5 triangle. That's a Pythagorean triple. So this side is 4, and because it's to the left in the xy plane, the x value is -4. So that is for alpha. And beta is in quadrant 1, and the sine of beta is 1/2. So beta is in quadrant 1. Sine is opposite over hypotenuse. This is beta. That third side is going to be √3 because if the sine is 1/2, then the cosine is √3 over 2. Cosine is adjacent over hypotenuse. So that's how that works. Or you can do that with a Pythagorean identity. You have x squared, you don't know, plus y squared, which is 1, equals the hypotenuse squared. So you have x squared plus 1 equals 4. So x squared equals 3. So x is plus or minus √3. Since we're in quadrant 1, it's +3. Okay. So then let's do each of these. We'll do sine of alpha minus beta. My point is that students and I forget the rules here. So sine of alpha minus beta, I need to use the difference formula for sine. So that's going to be sine, cosine, cosine, sine. With the same sign in the middle, you get an alpha and a beta, an alpha and a beta. So what we need to know is what is cosine of alpha and what's cosine of beta to fill this stuff in. So I'm going to go over here. The cosine of alpha is going to be adjacent over hypotenuse, so the blue stuff, that would be -4 over 5. And then the cosine of beta is going to be √3 over 2. Okay, so now we can fill in. The sine of alpha we were given is 3/5. The cosine of beta we just found is √3 over 2. The cosine of alpha we just found is -4/5. And then the sine of beta we were given is 1/2. We'll multiply these, you get 3 √3 over 10. Those negatives are going to cancel, so this will be +4 over 10. I'm going to write that as 3 √3 plus 4 over 10. Okay, then the next one we're looking at is the sine of 2 alpha. So this is the double angle identity for sine, which is 2 sine alpha cosine alpha. And we're going to fill this stuff in. So we get a 2 times the sine of alpha we were given is 3/5. The cosine of alpha we found is -4/5. Multiply all that out, we get a 25 on the bottom. 2 times 3 is 6 times 4 times -4, it would be -24. Okay, and then lastly, we have the cosine of 2 beta. Now you have some choices here on which of the 3 versions of the double angle identity that you want to use. I'm going to use cosine squared beta minus sine squared beta. So cosine of beta is √3 over 2. So we have that squared minus the sine of beta squared. The sine of beta we were given is 1/2 squared. √3 squared is just 3. 2 squared is 4. 1 squared is 1. 2 squared is 4. So 3 minus 1 is 2 over 4, which would be 1/2. And there you have the double angle identities, also sum and difference formulas at play in a triangle problem.